What is up, guys? Forrest here. Yesterday in the live stream, I was talking a little bit about how I kind of wanted to connect the dots for any newcomers and even for more advanced people for the later on steps when it comes to software development. Basically take you everywhere from downloading the IDE, which is basically like 2 seconds of this video, to creating a simple terminal application within that IDE, writing a few tests for that terminal application, because we're going to be pushing it up to GitHub, creating our own GitHub repository and whatnot, and then going ahead and using Circleci to integrate some continuous integration, and those tests are going to be run through Circleci before it pushes it over to our master branch on our GitHub repository. That is why I say it's for beginners and people who are a little bit further along, because if you have no experience when it comes to CI/CD workflows, that's something that you're going to run into one way or another if you plan to become a professional software developer. So I think that anybody of any skill level, from beginner to, I mean, maybe you've been doing this for a while, will take something away from this video. At least that is my hope and plans. Quick disclaimer, I'm not sure how good of a teacher I am. Sometimes I tend to just gloss over some important facts because I may assume that you already know it. Other times I may fall down a rabbit hole because I don't think you know anything about it. So we'll see how this goes. All of this is being done on Windows 10, and I can make any argument in the world as why maybe you want to be using Linux for a software developer, but I just want to break down the barrier to entry. There are so many different questions when it comes to Linux and the distros and things of that nature. So we're going to be running it on Windows 10. If you have Mac OS, this should be the same exact thing. And I also want to mention before we get started is that Circleci is the sponsor of this video. And while we are going to be going over a little bit of, I say a little bit, we're going to be setting up a CI, a continuous integration workflow for a very simple terminal application. Circleci does a whole lot more than that. I just want to read a few notes that I took down on my experience in Circleci that for some of you who are a little bit more advanced and want to do a little bit more, maybe hop into the continuous deployment side of things, as well as the continuous integration like we'll be doing in this video. Circleci, this is my own notes, professional service, something you'll see in top companies like Facebook, Spotify, Kickstarter, and GoPro. It allows debugging in your CI/CD pipelines with SSH. You can use workflows to schedule jobs, share data among jobs, where each workflow has an associated workspace which can be used to transfer files to downstream jobs as a workflow progresses. Caching dependencies is another big one. It makes jobs faster in Circleci by reusing the data from expensive fetch operations from previous jobs. And you can use the Circleci CLI to split tests. All of that I just mentioned is available for free. On their performance plan, however, they offer even more, like resource classes, scaling concurrency, and Docker lane caching. If anything I mentioned or everything I mentioned went right over your head, I'm going to be leaving links down to the appropriate Circleci page for everything I just listed. So you can go ahead and click down there and just have fun falling down that rabbit hole, because there's a whole lot to learn when it comes to CI/CD workflows and things of that nature. And like I said, professional software development environment, you're going to be using continuous integration and/or most likely and continuous deployment. So it's definitely something worth learning if that is your ultimate goal. All right, first things first, eclipse.org/downloads. You're going to download Eclipse for this particular project because we're going to be creating a Java terminal application, Caesars Cipher. I'll explain that in just a second, but basically all you do is at eclipse.org/downloads, download whatever it suggests, probably your 64-bit if you're on Windows 10, click download. And you're going to be downloading this right down here. It's going to be an executable file, and just follow the prompt. Sometimes there's different options like, oh, do you want to do custom settings or just default settings? If you don't know that you want either one of those, just do default. Eclipse knows what you need better than you if you don't know that you need something specific. I really love cryptography and puzzles and just things of that nature, and the fact that CaesarsCipher is a very, very simple cipher, something that I think y'all will be able to just catch on to in an instant if you don't already know what it is. And the program itself is fairly simple, and I already know what I have in mind when it comes to the tests. That is what we're going to be doing today. If you don't know what CaesarCipher is, all in all, CaesarCipher is an encryption technique, a very, very simple encryption technique at that. What you do is you take the alphabet, you shift it down a certain amount of letters, and that is how you write your message. And what we'll be coding up is the ability to take a message, throw it into our code, and our code is going to spit out the encrypted message using CaesarCipher. All right, so you want to be able to pull up Eclipse. I'm going to use this as the default, and do not ask again, please. This is Eclipse workspace. This is where your project is going to be saved. You're going to get this page when you first open Eclipse because they're going to try to recommend you, they're going to try to steer you in the right direction. And I do, after we go through this terminal application through this video, you take a look at the overview or maybe some tutorials or samples, because the more you're exposed to what is going on within your IDE, the better you'll be able to use it. The more useful it'll be for you. Knowing your IDE is just as important as knowing your language, is just as important as knowing how to write tests, and all of this plays into the part of being a software developer. But we're going to close out of that, and as you'll see, it'll give you a few options what you can do right here, or you can come on up to File, you click on New, and it has this window right here. Now, normally what you would do potentially is come up here and create a Java project, but since we're going to be creating a continuous integration workflow, what we're going to need to do is come down to Other, and we're going to be creating a Gradle project. So under here, you'll see Gradle. You'll see Gradle project. We're going to click on that, click Next. We're going to name this project Caesars Cipher, just as such. All right, next. I think everything else is just fine. Now we're going to click Finish. And it's going to do a lot of work over here. Don't seem too intimidated by what we got going on over here. So we have source main Java directory, we have our Caesar Cipher package, and we already have a library.java file. Don't worry about any of this. We just need to create it as a Gradle project in order for it to work properly when we implement the continuous integration with Circleci. So what you want to do is, obviously you'll see your source main Java. Now you can create it right in here, or if you want to keep all of this stuff closed, you see you have this source file right here. And then we're going to come on here, right click main, we're going to hover over new, we're going to go down to class. This is your Java class. We're going to name this. Now, naming conventions, while they don't necessarily matter too much when it comes to the project itself, when it comes to the Java classes, make sure you capitalize every single word, just like that. This is going to be Caesar Cipher. We don't need to make a main right now. We'll make that later, and finish. Now, this is a part where most people can get to and think, I don't know where to go from here, because like, what do you start typing? Like, what do you start typing here? Well, you got to think about whatever project you're about to build. We're going to be building Caesar Cipher, and obviously we have an understanding of Caesar Cipher. This is when this notebook can come in handy. You could write down exactly what you need, the objects in which you'll be using. So let's just talk about it here. So we're going to need the alphabet, because in order to implement Caesar Cipher, we're going to have to shift it down a certain amount of characters down the alphabet. So we're going to need the alphabet. We'll start off there, and then we're also going to need to be able to implement that shift or that offset. And then we're also going to have a message in which we offset, and that's going to turn into the ciphered message. So let's just start there, and I'll talk about it towards the end of me coding all of this up. All right, this is a good place to pause, and that is because we have this red underline right here, and I say pause by me explaining to you what exactly I just did within our public string cipher. So we have our input parameters of our cipher. So this cipher, when I say cipher, this is the message encrypted. This is the encrypted message. So what do we need within that? We need the original message, and then we need the offset. So the offset in which you are applying to your message. And here's the thing. We want to make sure that the offset, because it's going to be an integer, it's going to be a number in which we offset it by, does not exceed 26, because we can only offset it by up to 26 letters. Offset module equals alphabet size, and that'll allow it to avoid overflowing over 25. So basically, another way to write this, I'll just write it like this: offset equals offset module alphabet size. And if you're wondering how I did that just there, let's take a step back. Where I typed in the beginning of something I've already declared, AL, alphabet size, control or command, space, alphabet size, okay, and so I don't have to type it in every single time I want to do that. There's a lot of little shortcuts like that. But this right here is the same exact thing as this right here. So in case you wanted to see it, where it makes a little bit more sense in your head and more traditional manner of looking at things. But we're going to take that out, and what we have going over here. So we have our string. We just declared a character array. We called it character, and we have a string message, and we're going to take the message, the string message, and we're going to turn that into characters and store all of the characters into our character array. So if we have 25 characters within our string that is stored within message, it could say, how are you doing today? Each one of those characters, H, O, W, those will be stored as characters in our character array that we called character. And what we have going on over here is shift. This is our shifting. This is the same as offset. In all honesty, I could name this offsetBy. Let's do that so we stay consistent. So offsetBy, this is going to be our method offsetBy. We're going to create a new method there, and it's going to be calling in the parameters, our character from our character array, and the offset. What this code is doing right now is calling this method right here. Basically, so whenever I call this method offsetBy, it offsets our message to how we want it. And then return new, if you notice that if I took out return new right here, it's yelling at us up here, and that's because we need a return statement with this. So return new string character. What we're doing is basically when we go through our string cipher, we go through all these statements right here, what we end up with is our character that we are converting to a string, storing in a string. Now onto offsetBy, we just had to throw in the logic there. So whenever we call this method right here, it actually does something. All right, and this is our logic right here. So let me explain this for a second. One, this is yelling at us for the same reason that the offsetBy was yelling at us, because we need to create a method out of what we have going on right here, and then we're going to add a little bit more logic, and then we'll be done. So that is the offsetChar. We'll get to that in a second. But let me take you back to the for loop. So this is just a regular for loop. I'm going to take you through it anyway, but just know that, hey, it's a regular for loop. So we declared an integer I. We're going to be using this only in the for loop, and we equaled it to 0. And then we have while I, which right now equals 0, is less than character length, we're going to be doing whatever's in the for loop. And every time we do a rendition of what's in the for loop, we're adding 1 to I. So next time it comes through, I is going to equal 1, and then it's going to equal 2. And the thing is with character length, that is the value of how many characters are within our character array that we determined up here, which is obviously storing our message as each individual character in the array as we previously discussed. And how many characters, like I said, if it says, how is your day today? However many characters that is, let's say it's 15 characters, this right here basically just equals 15. So while I is less than 15, we're going to keep on doing the for loop. And also within this for loop, what we're doing here, we have our character I. And with I, we are running through each and every character that is within our message. That's all that I represents. So 0, while I equals 0 up here, as we go through the for loop, I will equal 0, or I will equal 1, and then 2, and then 3, and then 4. And that will represent the position in which the character is within our character array. You with me in that? And then we're also running this method that we just created and we're about to throw logic into in a second, which this is our message traversal. This is us implementing Caesar Cipher into our character, into our message, and we're just storing it within this, right? So now what we need to do is our offset character, throw the logic into there. So I mentioned our previous method where we're going to have letter A and letter Z, and we're going to assume that every character in our message is lowercase. We're representing a lowercase a and a lowercase z, and we don't care about the uppercase because we have control over the message, so that is what we have decided together. Within our offsetChar, we are also only allowing us to do a left rotation. We're going to be looking at the lower bounds with this if statement right here to account for a left rotation. To put in perspective, if you have the letter E, if you want to shift it, the whole entire alphabet around the letter E, 3, the amount of 3, you could do E, F, G, H, or you could do E, D, C, B. So that's 3, but that's either way. We're only allowing for a left rotation. If we wanted to do a right rotation as well, let's just add that in there. Why not? It's basically the same exact thing that we got going on here, but we want to shift around the less than to a greater than. and it's going to be greater than the last character of the alphabet, and that is the letter Z that we have determined up here. And then we also want to do C minus alphabet size, not C plus alphabet size. So we just changed up a few things, and then we obviously changed return 0 to return C, and this is Caesar's Cipher. However, since we're doing everything in Eclipse, the way that we want to run this, and in order to make it cleaner, we want to create a main.java file, and we're going to be creating a main method within that main.java file, and that is basically going to be our operations. That is what we're going to say, hey, run this, because whenever we click this run button up here, it's going to look for our main method, it's going to run our main method, and then we'll start basically doing all of this code from our main method, but we'll get into that. We come down under source, main, right click, new, and we're going to create a new Java class. So under Java class, we're going to name this main, remember capital M, and which method stubs would you like to create? We're actually going to create a main method. We're going to check that and click finish. So this is what we're going to do within main. While we are going to be calling our cipher here, we're also going to be determining, hard coding in, for the purpose of this, so you can actually see how everything works. We're going to be hard coding in the message. We're going to be hard coding in the offset. We could prompt the user actually, if we wanted to type in the message and then type in the offset. I don't know. We'll figure that out here in a second. But what are we going to do? We're going to have Caesar's Cipher. So we need Caesar's Cipher here. Let me take a second right here. I know I was previously going through the whole entire code and then explaining it at the end, but as I do it, I think it would make a little bit more sense. Okay, let me take it back a step. So Caesar's Cipher, this right here is a whole entire representation of this file right here, this class, I should say. So this class, Caesar's Cipher, we created an instance of this class within our main with this line right here. So Caesar Cipher, that is obviously referring to this class. We just named it Caesar Cipher. We could name this whatever we wanted to. We could name this Bob. As long as we call it as Bob, it doesn't matter. But conventions, you name it the same exact thing, you just lowercase it. And then it gives you the ability to call anything, any object within that class. And it has a list right there, but if you have a lot of objects within your class, you can just start typing and then it'll obviously filter out. Hit enter, and now it's asking us, okay, we need to fill in the message and fill in the offset. So what we can do here is we could create a variable that is message. Let's just do that, message and offset. Everything is separate when it comes to this particular class and the other one. So right up here, let's just create message. What is message? Message is a string. How are you doing today? Remember, we didn't take into account any of this, any special symbols and uppercase. So what I'm doing right now, I think I'll just ignore the special symbols, not 100% sure, but what we're doing right now, how are you doing today? And then we're going to throw that into Caesar's Cipher. We're going to have an int offset, and we're going to put an offset of 12. I'm gonna format this a little bit better. I'm gonna keep that there. I'm gonna keep that there. And this is what we got going on. So if we come on up here, we click run, main Java, it does all of the work, but it doesn't tell us anything because we haven't printed out any of the work. So what do we want to do here? All right, so let's take a second right here because I made a mistake. Obviously, I didn't test my code thoroughly beforehand. As you can see, it ciphered our message, and I'll explain a little bit as to why here in a second. But it ciphered our message, but it also shifted all of our spaces. So you can see space, 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 space. So these are after 3 characters, after 3 characters, after 3 characters. So 3 characters, space, F. 3 characters, F. 3 characters, F. 5 characters, F. Capital F. So what we did here is we forgot to basically ignore the spaces, not within our character array, but within our cipher. So what we're going to do here, within our character, we're going to do an if statement. If. All right, so what we've done here, I'm going to save that. So if character I does not equal space, then we're going to offset the character by what we're doing all within this method that we called up here. Now it should work. All right, let's test this out. Cool. All right, now that we have everything printing out exactly what we want to, we have our original message, we have our offset, and we have our ciphered message. We actually have a little bit of redundant code. So since we're printing out our ciphered message and we're running the code right here, we don't need this code right here. So we could delete it. We also could run this code and assign it to, we could say string ciphered message. And we could basically, let's do that. So just so that it's a little bit more clean, a little bit cleaner. All right, and that should do the same exact thing. That should do the same exact thing here. All right, cool. So now that we have exactly what we want printed out and our code seems to be working as planned, allow me to take you through basically the order of operations that happens, that Eclipse does when it runs our code from the time we click this run button to the time it prints out what we got going on down in the console. So whenever we start off, we click this run button, it looks for our main method. So our main method is right here in our main class and it runs this code. But not all of it at once, it goes line by line. So on line 7, we're declaring our message. We want our message to say, how are you doing today? This is the message that we want ciphered. And on line 8, we're determining the offset of that message to be ciphered, and that is the value of 12. Pretty simple stuff. On line 10, what we are doing is we are creating an instance of the class CaesarCipher, and we are giving it the name CaesarCipher. So every time we call CaesarCipher, which is right here, we are basically accessing, putting our hand down into the class that is CaesarCipher. So now we are able to access all of the code within these curly brackets right here, which is all of the code. So we can even access letter A or letter Z or alphabet size. All of these are objects. Creating an instance of CaesarCipher, we're able to access those objects. And that is exactly what we're doing on line 11. So on line 11, let's look at the code that is being executed. Remember, this code on the right side of the equal sign, whatever the result of this is going to be stored into ciphered message, just like the value, how are you doing today, is being stored in the string message, or the value of 12 is being stored in offset. Every time you use offset, that is just a representation of 12 because that is the value in which it is storing. Every time you use ciphered message from here on out, which is right down here, you are accessing the value in which is stored in there after running this code. But this is where we basically run all of the code. So CaesarCipher, that is obviously the instance of CaesarCipher class. And what I say before, we want to be specific with what object we choose to dip our hand down into. So we said, hey, we want to access the method cipher. So we're going to be accessing the method cipher that is within the class CaesarCipher. We're going to be passing in our own parameters of our string message, which is how are you doing today, and our int offset, which we have given it the value of 12. All right, now let's get into it. Within the cipher, what are we doing here? So we have our offset. Now this is now equal to 12. And this message right here, this is now equal to how are you doing today? So now that it's in our method cipher, it is going to start running the code. So line 10, it runs line 10, it runs line 11. And remember, line 11, that is turning our string called message, which is how are you doing today, into a character array called character. And then on line 12, we are going to be calling offsetBy, the method offsetBy right down here, and passing in the parameters character and offset. And then basically what on line 12 it is going to access all of this code, it's going to run all this code, it's going to run the for loop as long as it allows, it's going to hop into the if statement as long as the character I does not equal a space, and then it's going to run line 19. Now remember, on line 19, we are running this code and we're actually going to be storing it within character I. So this code right here, this is us calling the offsetChar method down here, passing in our parameters. So every time we come through a letter, we run all of this code, return the new letter to be stored within character I. So basically it comes down to the H. The H is offset by 12, and now that H equals a T, we return T into our character array, and then we go on to O, and O is offset by 12. That is now an A, we return A, and now that is being stored in our character array, so on and so forth. You get the idea until we are at the end of our character array. And then on line 13, what we're doing is we're returning new string character, which now no longer equals a character array of our message, how are you doing today? It now equals a character array of our ciphered message, which is it's not supposed to mean anything. That's the whole point of ciphering a message. But now this right here is stored within this, because this line 12 ran basically all of this code, which ran all of this code. I just love it. And then, so now that we are out of our cipher method, and remember, the last thing we did in our cipher method was return our character, which is now this, and we are going to be storing it, because remember, everything that we just talked about is this right here, and we're going to be storing it, our character, what we returned in our cipher method, into our string ciphered message. You follow me here? And what we're doing down here is we're printing out our original message, which is how are you doing today? We're printing out our offset, which is 12, and we're printing out our ciphered message, which that we ran all of this code is I'm not going to say all that again, but that's what it is. And that is exactly how this code works. Now let's write some tests. We already have our CaesarsCipher.java. We already have our main.java. And just as we created those down under source main, we're going to create the test under source test. Makes sense, right? We're going to right click, go over new, not go over class. We're actually going to come down here and we're going to create a JUnit test case. Since we're writing these tests for CaesarCipher.java, we're actually going to name this CaesarCipherTest. And the only change I'm going to make here is select new JUnit Jupyter test instead of JUnit 4 test. We're going to click finish. We're going to add the JUnit 5 library to the build path. Okay. And now it's time for me to write some tests and hope that they work. I'll get back to you. All right, so we have two tests here that should work. They're telling us that they should work, but let me explain a little bit of what these tests are actually doing first. So first and foremost, we have to create an instance of CaesarCipher within our test, just as we do with main, because we need to access that. And then our first test, test ciphered message with offset of 12. Test names are typically very, very specific to what they're actually doing, so you avoid any type of confusion, because maybe you want a test ciphered message with offset of 11. You want to make sure that it's very specific. Assert equals within our test. This is basically saying that this on the left side of this comma right here is equal to this on the right side of this comma here. We are asserting that these two values are equal. So let's actually take the right side of it first. CaesarCipher.cipher, and we're passing in the message, how are you doing today? And we're offsetting it by 12. Well, we've already done this. We know that if we pass in the message, how are you doing today, and offsetting it by 12, just as we see down here, our ciphered message is this. And as you can see, this is the same exact as what we have right here. So yes, this value is the same as this value. This test should pass. And then on our second test, we are testing an empty string. We're doing exactly that, throwing in an empty string within our cipher right here. We are saying offset this by 12, but since there's no letters and it's an empty string, we should get back the same exact thing, which is an empty string. So in theory, this test should pass as well. As a matter of fact, let's go ahead and test this. We can right click, come on down to run as. Right now, we're gonna run it as a JUnit test. All right, cool, very nice. We tested it. All right, test ciphered message with offset of 12, passed. Test empty string, passed. Now let's do a failing test. All right, well, this is our failing test. Very quick. All we're doing is testing ciphered message with offset of 11. We change the offset. It's the same exact thing as this. We changed the offset from 12 to 11, but we kept this value the same, meaning it should be wrong. So we're going to come down here, run as JUnit test, and boom, it failed. Now there's two reasons a test will fail. One is that obviously the test is written incorrectly, but two, and this is the main reason you write tests, it shows broken code. So if we know that this, right here, this 12, offset of 12, we know that this value should be equal to this value, but it's not, that means our code is wrong somewhere. That means the offset is incorrect. Maybe the way you put it in the array, maybe you added 1 and now the offset is all weird because the array started 0. It could be anything, and that's when you have to start digging into why is this test failing. But for now, I'm actually just going to comment this out, highlight all of it, control/comment it all out, save. Cool. All right, so cool. We know our tests work. I'm going to run it one more time just to make sure. JUnit tests, okay, those work. I'm actually going to come back on over to our main.java file, come over here and click run to make sure that works. Okay, that works exactly how it should work. I just want to test that out because our next step is creating a GitHub repo and pushing all of this code up to the GitHub repo. And you always want to make sure you test your code, test your test before you push it up to your remote repository. So you want to come into your GitHub account. I'm obviously logged in as myself, github.com/forestnight, in case any of y'all want to follow me. And you want to come on up here. You can click new right here, but this one's all, regardless of what screen you're on, hit the down, new repository. We're creating a new repository name. We're going to name this Caesars Cipher YouTube. And now with you could make this public, but since I'm creating a video and y'all won't be seeing this, I will make this public eventually, probably whenever this video goes live. But for now, I'm just going to make it private. I'm not going to initialize a README. If I wanted to create a README, I could just do that in Eclipse. I'm going to create the repository. This is what an empty repository looks like. But for now, we're going to hop on it back into Eclipse. So we want to hop on over to our Package Explorer window right here. This is obviously our Caesar Cipher project. We're going to right click on Caesar Cipher, come down to Team, and over on Team you'll see Shared Project. Click on that. And right on here, this is our configure Git repository. Basically what we're doing right now is we're creating a local Git repository. That way it'll be consistent with a remote Git repository that we just created on GitHub. And for this particular instance, we're going to user create repository in parent folder project. We're going to click on that. We're going to come down here. We're going to check this. We're going to create a repository right here. And we're going to click finish. We should be good to go. Now what you want to do, there are different ways to do this. There are different ways to do all of what is mentioned in this video, but in order to take full advantage of our tools we have within Eclipse, we're going to come right over here to our upper right. We're going to hover over open perspective, click on that, and we're going to come on over here into Git. We're going to click on Git and we're going to open. Now this is pre-installed on your Eclipse, but just in case it's not for whatever reason, click on help, come down to Eclipse Marketplace, type in egit, hit enter, and install this right here. If it says installed, then you have the option for that perspective. So this right here, this is our Git perspective, and this is our project, our Git repository that we actually just created. That's our project. But we want to come down here to Git staging. You see this is the middle tab. Git staging, you'll notice that all of these are unstaged, meaning that these are inconsistent with our remote repository. We want to stage all of these. We want to type in, this is our initial commit. But before you commit, I do want to point out something. When you come down to author and committer, you may notice that it is your actual PC user that is your author and your committer, but you don't want it to be your PC user. You want, when you commit up to your GitHub repository, to show up as your GitHub user. Otherwise, it'll show as a non-GitHub user and it'll actually say whatever your PC name is. You don't want that. So in order to fix that, what you do is you come up to Window, you come down to Preferences, you type in Git, and it'll say Team Git Configuration. So you want to type on configuration right here, and it'll open up with this table. If it doesn't open up with this table, click on user settings, and actually your table will be empty. It won't have anything. I've already added my user. But what you want to do is you want to add entry. You want to type in user.name, and your value is going to be your GitHub username. Mine is obviously ForestNight, and you want to add. And then you add entry again. You do user.email, and your value is going to be your GitHub email. Click add. You want to apply and close. And then now you can change your author and committer to what you just added. So exit out of that, start typing in your GitHub username. Mine is ForestNight, so I can click right here and add it as ForestNight. Same thing for committer, same exact thing for committer. And just make sure it is consistent with whatever your GitHub username and user email is. If it doesn't show up under that drop down, just type in your username, do a less than sign, type in your email, greater than sign, just as you see formatted like this. And we're going to commit and push to our master branch now. Now what you're doing is you're going to connect this local Git repository right here to your remote Git repository right here. And how to do that? make sure that HTTPS is selected. Come on over, click copy. That's what that button does right there. Go back on over to Eclipse, and under location URI, you want to paste in what you just copied. Your user and password will probably not autofill like mine did, but for user, type in your GitHub email. And for password, type in your GitHub password. That is how your local repository is going to be able to communicate with your remote repository within your GitHub account, okay? Preview, everything looks good to go. Preview, okay, and push. Cool, and close. Now what that just did, it pushed all of your code and all of those files up into this repository right here. Just click F5 or refresh, and now you can see all of your files. Cool. Now it is time to implement a continuous integration workflow using Circleci. Now, the link to this is going to be in the top of the description. Click on that and it'll take you to this page right here. Obviously, what you want to do is sign up with GitHub. I'm already signed up, so I'm going to log in with GitHub. Wherever it ends up taking you, whether that be your project dashboard or your workflow, pipelines, wherever it may be, come on over to Add Projects. And you will notice that all of your GitHub projects are listed in here, private and public. Obviously, this is our Caesars Cipher YouTube project, and we want to set up this project. Obviously, our project is a Gradle Java project. That is why we created the project as a Gradle project instead of just a Java project in order for all of this to work. And we're going to start building, but we need to make a change first. Go on over into Eclipse. You can change back into your Java perspective right here up in your upper left. And we're going to come down to our build.gradle file, and we're going to add two dependencies. We're going to add a new test implementation. We're going to add a new test runtime only. Now we're going to keep this old test implementation as well. The reason for this is because our JUnit test that we wrote within Caesar Cipher test, this is using, as you can see, JUnit.Jupyter.api, JUnit 5. I mean, you can see that JUnit 5 is right here in our project. We could have chosen JUnit 4. I want to use the latest and greatest. So JUnit 5. And within our build.gradle file, we just need to ensure that test implementation JUnit.Jupyter version 5 is what we implement. Test runtime only JUnit Jupyter version 5, same exact thing. I also want to note something that I previously forgot to add into our build.gradle file, and that is underneath our dependencies, we're going to add a test. So within our test, we're going to have use JUnit platform. Otherwise, when Circleci it does its job and runs our tests, it won't be using the JUnit platform, so it won't recognize a failing test versus a passing test. So we need to make sure that we have that into our build.gradle file. And what we're going to do is we're going to stage our build.gradle change. So hit the plus sign, okay, it's staged. And we're just going to say updated Gradle file. Going to commit and push. You'll notice back on over here that we just updated Gradle file just now. Cool, everything is connected. You could just go into your Git perspective within Eclipse and you're good to go. Now we're ready. Now we're going to come back on over to our Circleci setup and we're going to start building. Now what this is going to do, add this config to your repo, is to create a new branch on the user's project called Circleci-project-setup. And that is to add a Circleci config template based on your language, which is located in a newly made .circleci directory called config.yaml. Now this is done on a separate branch so you can test your configuration like you would any other code. Add config. It'll take you over to our pipeline. You'll see that it is running, and we can only hope that it works. And it did. Wow, cool. That took 25 seconds. We can drill on into this, click on success right here, and you can see step by step exactly what the config.yaml file is doing for us. So it starts off with spinning up the environment, which is creating a Docker container and running this image in here. As you can see, the image is cached as circleci openjdk 8 jdk. You can see where we told it to do that in our config.yaml file. Build Docker container with this image, and then it starts preparing environment variables, where using build environment variables, all of these are environment variables. We specifically declared our working directory as this repo, where as you can see, our repository URL is Caesars Cipher YouTube on our GitHub, repo name is Caesars Cipher YouTube, so on and so forth, and we're taken from branch Circleci project setup, and then it checks out our code. This step right here will check out our project source code into our working directory, and then we're restoring cache, whereas we don't have anything cached just yet because this is our first build. Next step is Gradle dependencies. Obviously, if you recall, we added in a Gradle dependency, if I can find it right here, to run our JUnit tests. Those, along with the boilerplate Gradle dependency code, are being run right through here. And then we are saving cache to be used in future builds when we are going to be restoring the cache. So in build 2, restoring cache will pull from our saved cache. And then we are running our Gradle tests, our JUnit tests. And how it's able to do that is because we added those Gradle dependencies for our JUnit tests. Now we can come back over and see a little bit more in depth of what it did. So notice right here, it says one branch, because right now we have a master branch. We refresh this, and you'll see now that we have two branches. We can view our two branches. We have our master branch, but we also just created that new circleci-project-setup branch via circleci. I'm actually going to drill on into this. We'll obviously see that our latest commit checks out. Code builds, test pass, cool. And if we wanted to, we can click on this, compare and pull requests. And I am going to create this pull request, merge it on over. All right, all checks have passed. That means our CircleCI jobs have passed and that this branch has no conflict with the base branch. We can look at all checks and that it's CI CircleCI build your test pass on CircleCI. That is our CircleCI job telling us that our test that we wrote passed and this is safe to merge into our master branch. Now what I'd like to do is merge our pull request into our master branch. So this is taking everything from our CircleCI project setup that is different from our master branch. Obviously that is our config.yaml file, and we're going to merge that pull request, or in other words that code, over into our master branch. That looks good. Confirm merge. Now you can see that we have our config.yaml file merged on over into our master branch. Now, something to note is that one of the main reasons why you have multiple branches, well, there's a few main reasons. One, you're implementing a new feature. So you have a ticket, you're working on this feature, and before you push it into the master branch for all of production to see, you push into your feature branch for CircleCI to run all your tests, do the CircleCI jobs, and make sure that your code is good, but also for code reviews to ensure that you are writing the code in the best possible way. And if not, then your team can help you write a little bit better code. Another reason is you can have multiple different branches you can have for development, and that is what your development team works on before it goes up to a QA branch where you have people, whether that's end users or QA testers, testing it, and then up into production branch, and of course that goes to a production server. So with this, what we just did is we just added our config file to our master branch. We can delete that branch that we just had because once you merge it over into master, there's no reason to keep it other than for record's sake. And for this particular instance, we're just going to delete it. So you can just click on branches right here. Come on down, you'll see your branches, active branches, CircleCI project setup, and we can trash that. All right, refresh this page and you'll see that it is no longer there. As you can see, what we have left is our master branch. Now what I want to do is show you what happens when we throw in a failing test, remember the one that we wrote earlier right here, into the mix to see exactly what CircleCI will do. Now, before we do anything, what we're going to have to do is come over here, right click and pull. We're going to pull down the merge, that code that we merged from our CircleCI branch over into our master branch. So we're going to pull that down. We're going to merge when pulling, okay. And good to go. All right. And that just pulled down that config.yaml file from our remote repository up on GitHub down to our local repository here on our local machine. As you can see, what we can do now is stage our change, but we're going to hold off on that. We need to right click on our CaesarCipher Git repository directory right here. And we're going to come down or right here to switch to new branch because this is technically a new feature. We're adding a test. Well, branch name could be feature test 1. All right, that works for me. We're going to check out new branch and finish. All right, cool. So now we're going to be pushing up to a new branch. We're going to stage these changes, add in a new test, commit and push. We can ensure that our branch is feature test 1, next. All right, looks like everything worked, and finish. You can see that our config.yaml file that we had pulled down from our master branch and pushed up to our new feature test 1 branch is running. And then right down here, you can also see that when we merged over our config.yaml file into our master branch, it also reran that, did our CircleCI jobs, and obviously it was successful because it was the same exact code, but obviously it failed here because we introduced a failing test. So let's take a look into that. Within our Gradle test, that is where we expected it to fail. Obviously, when you are in the real world, you're not knowingly introducing a failing test. So what you would want to do is come down over here to Gradle test and take a look at what it's telling us. So you can see right down here, task, test failed, and it'll let you know exactly what failed. So within our CaesarCipher test class, we have our test ciphered message with offset of 11 method that failed. And obviously, if we come back on over here, we can see that our method within our CaesarCipher test class test ciphered message with offset of 11 failed. Now we discussed earlier in this video why this was a failing test, because we were asserting that this value is equal to this value when in fact it is not, and it gave us a good look at what it looks like when we introduce a failing test into our code, and this is what it looks like in our circleci workflow build. Now remember just a second ago where we had a successful circleci build and it told us that we were able to merge our pull requests? We can't do that now because we have a failing circleci build. Therefore, they're not going to let you merge that over to our master branch, which is, I like that. And that is how you go from having nothing but a Windows 10 laptop to a working, running Java application up on your GitHub repository with a continuous integration workflow thanks to a circleci. Hope you guys enjoyed this video. It was a lot of work, so please, if you did make it this far, if you did like the video, if you found any useful information out of it, give it a big thumbs up, share it with your friends, and don't forget to check out circleci. All of the links are down in the description below.